All right, so hydrogen and oxygen. The hydrogen atoms are seeking one more electron, just one more, and they will find their magical number. All electrons will fill that outer energy level. Oxygen on its outer energy level, it's not full. It needs two more to hit that magical number of 8. All right, so whenever these two elements bind, these total of 3 atoms, 1, 2, 3 atoms, when they combine, they create a very happy, very unreactive element. If we go back to sodium, do you realize you put sodium into your body every single day? However, it is combined with chlorine. Do you know what it is? It's salt. Sodium chloride is salt. We put it in our body every day. So once these elements combine together, chemically bond together, what could be really reactive turns into something that is not reactive and in fact is necessary for life, whether it's salt or water. All right, moving on to energy levels. Energy levels, the first energy level of atoms needs just 2 valence electrons to be full or happy. So hydrogen is just looking for one more for a total of 2 electrons. Energy levels after the first one, so such as oxygen, or any of the ones that we looked at here, that second energy level definitely wants a total of 8 electrons. That full outer energy level is the most stable arrangement of electrons. That's what lets an element go from catching on fire in water to something that you put on your popcorn and eat while you're at the movies. All right, there are 3 main types of chemical bonds. We have covalent, say that with me, covalent. We have ionic, which are not iconic, they are ionic. And then we have metallic bonds. We will primarily talk about covalent and ionic bonds, but just so you know, there is a third. Covalent bonds are kind of the nice bonds. They are between 2 nonmetals. They share electrons. The biggest importance here is that they share electrons. They're very polite, they're very nice to one another. No one's rude. Then we get to ionic bonds, and they're usually between a nonmetal and a metal. So let's look over here and remind ourselves what a nonmetal and a metal is. So a nonmetal would be our blue or green, such as over here, and our metals are going to be pretty much blue over. So when we talk about sodium and chlorine, sodium chloride or salt, that would be an example of an ionic bond, because that would be between a metal and a non-metal element. These bonds give or take electrons. So one atom might give up their electron and say, I really didn't need it that bad. Or maybe they're really, really hangry and they really need that electron and they're really grumpy and they're not going to be happy till they have that electron. That would be an ionic bond. And then lastly, metallic bonds are between 2 metals. All right, let's think of a covalent bond. Let's see here, 2 nonmetals. Let's see. Ooh, hydrogen and oxygen. Why, by golly, that's water. H2O, so 2 hydrogens, 1 oxygen. They share their electrons. All right. Thanks so much, guys. If you have any questions, comments, concerns, please come tell me.